Let us understand to find the integral for such problems using an algorithm. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss how do we do integration when radicals are involved. So in this particular playlist, we have taken many examples. This is indeed question number 3, which we'll do. But we are going to solve question number 4, 5, and 6 also using this technique. In earlier videos, we took up examples with product of linear and a radical function. Now we'll consider quotient of linear and the square root function. So let's try to understand the strategies involved to solve such problems. So we actually make things very simple for you. I hope this strategy helps you to understand complete concepts. Let me also thank all the viewers and subscribers for watching my videos, posting excellent comments, and also especially those who are contributing. Your donations make a huge difference. You are supporting millions of people globally who do not have access to quality education. Our free quality videos help them to master concepts and do exceptionally well. Many of my students in remote areas are joining American and Canadian universities. So please do support us. Thanks. Now let's look into the question and how do we solve it. Well, the strategy is when you get this kind of a question, which is x plus 1 over, we have square root of x plus 3. The idea is to write this expression with something x plus 3 so that you have one radical, right? So, how could you do that? I can write the numerator as x, I want x plus 3. So, how do I get plus 3 here? Well, by adding 2 and subtracting 2, right? Makes sense. That will make the numerator as x plus 3, right? So, we have actually partially factored the expression, you understand? So we could rewrite this expression as x plus 3 combining the 1 and 2, right? Minus 2, right? And over square root of x plus 3, you understand? And this also over square root of x plus 3. So the whole expression can now be written as x plus 3 to the power of 1 minus half, which is half. And here we have 2 times x plus 3 to the power of minus half. Makes sense. And now we can use the power rule, correct? Now you apply the power rule. Simple as that. So that is how we are going to, rewrite the expression. So let me write this integral as shown here as integral x plus 3 to the power of half, right? Minus 2 times x plus 3 to the power of minus half dx. Makes sense, right? And then we can integrate. You can now pause the video and answer this particular question, right? Makes sense, right? So let's take this on a fresh page. So what we now have understood that we can rewrite the integral x plus 1 over square root of x plus 3 dx as equal to, so I'll show you another method here, x plus 3, but it was plus 1, right? So I have to do minus 2, right? Over this radical, square root x plus 3, square root x plus 3. Do you see how simply we have done this, right? So understand this strategy, it will really help you. And of course, both will be in the bracket, correct? Now it is very simple. Since we could now rewrite this as equal to integral of x plus 3 to the power of half minus 2 times x plus 3 to the power of minus half dx. Is that clear to you? Now apply the power rule. So we have x plus 3 to the power of half plus 1, which is 3 by 2, over 3 by 2, minus 2 times x plus 3 to the power of half over half, and plus c, the constant. Now you can simplify and write down your final answer. So we have 2 over 3 x plus 3 to the power of 3 by 2 minus 4 times x plus 3 to the power of half. I could write like this, right? Plus the constant c. Makes sense. So that is how we are going to find the integral of such expressions. Clear? Now here is the second example for you, very similar. However, slightly more tricky. Since now, as you can see, we have 4x minus 3 in the numerator, but the denominator has square root of 2x plus 3. How do we work with this? Let's try to understand this, right? So see how we are going to do it. So let me show you here. We have 4x minus 3 over square root of 2x plus 3. So work with the expression first. So since we want 2x, let me just first factor out 4 itself. So I'm teaching you different strategies how you could do, right? 3 by 4, right? Square root of 2x plus 3, right? Makes sense? Now we'll multiply by 2 and divide by 2, correct? Because we want 2x. So you could write this as 2 times. So take 2 inside, 2x minus 3 by 2, right? Over square root of 2x plus 3. But we really want plus 3. We don't want 3 by 2. Correct? So now what you should do? You should rewrite this as 2 times 2x. We already have 3 by 2 here, right? We'll add 3 and we'll subtract 3. Correct? Know how? Simple steps. There are a few additional steps here, however, they help you to understand the concepts better. So now you have a term 2x plus 3, right? Also. So rewrite this as 2 times 2x plus 3 and over radical square root 2x plus 3. And the other term is minus 3 by 2 and minus 3. So we'll write minus. And what do you get? 6 and 3, 9, right? So 9 by 2 over square root 2x plus 3, correct? So we have rewritten the integral in that particular form. Makes sense? So basically, now you can write this as integral of 2 times 2x plus 3 to the power of half, right? Minus 9 by 2, 2x plus 3 to the power of minus half, correct? Dx. Makes sense? And now you can integrate it using the power rule, right? Know how, right? So this is the technique. So what you need to really learn here is how do we break it up into partial fractions like this. Is that clear to you? Right. So I'll leave the solution to you, but move on to the next one, where again we'll only learn the technique, right? So this time we have integral of 3x plus 2 over square root of 2x plus 3. Right? So let's do it again. So we have 3x plus 2, right? We are dividing it by 2x plus 3. So applying the strategy learned earlier, 3 common, x plus 2 over 3, right? Over square root of 2x plus 3. You want 2x? Go step by step. So you will multiply by 2, divide by 2, right? So you get 3 over 2 times 2x plus 4 over 3. Do you see? A lot of fractions involved. So I'm teaching you this technique so that you can later apply the power rule and easily do what you need. Now you need 2x plus 3. So add and subtract 3, right? So we can write this as 3 by 2, 2x plus 3, right? And then we write minus 3. And we already have plus 4 over 3, correct? Over square root of 2x plus 3. And this, we have two partial fractions have been done, right? 3 by 2, right? Times the first portion, which is 2x plus 3. And then dividing, you can write this as 2x plus 3 to the power of half, right? And then we'll do minus. Now do this math. So when you do minus 9 plus 4, you get 5, right? Minus. So you get minus 5 by 3. And you have 2x plus 3 to the power of minus half. Makes sense? Now once you have written it in this form, right, then you can substitute all this inside and write down the result using the power rule, correct? So simple as that, correct? So that is how you have to answer this question, right? So similarly, you take up the next example, which is once again we are now working with different types of examples, right? Just to help you. 4x plus 1 over square root of 3x minus 1. So you have 4x plus 1 over square root of 3x minus 1. You want to really get 3x minus 1 in the numerator, right? So what can you do? First factor out 4. So you get x plus 1 over 4, right? Square root of 3x minus 1. Now times it by 3, right? When you times by 3, you have to divide by 3 also. So 4 by 3, 3x. And times by 3 inside, so plus 3 by 4 over square root of 3x minus 1. Now we want 3x minus 1, right? So we'll write this as equal to 4 by 3, 3x minus 1 plus 1 plus 3 by 4. Clear? Over square root of 3x minus 1. So we get 4 over 3 into 3x minus 1 to the power of half, right? You see similar pattern of working. And then 1 plus 3 by 4 is 7 by 4, right? So plus 7 by 4. And we have 3x minus 1 to the power of minus half. Is that clear to you? So this square root 3x minus 1, we have a factor 3x minus 1 in the numerator. And the whole integral is written as 4 by 3. Let's find the answer for this one now, right? So we wrote this integral as equal to, let me see back, 4 by 3 and 7 by 4 are the two terms, right? So we have 4 by 3 of 3x minus 1 to the power of half, right? And plus we have 7 by 4 into 3x minus 1 to the power of minus half dx. Is that clear? So now just integrate using the power rule. So we get 4 over 3, 3x minus 1 to the power of add 1, right? 3 by 2. Here again you get 3 by 2, right? and times 3, right? So 3 times because of 3x in the denominator. Here we get 7 by 4, 3x minus 1. When you add, you get half, right? And then you get 3 times half plus c. Makes sense? And now write down your final answer. Simplify these expressions, right? So we have 8 over 27 in this case, and we have 3x minus 1 to the power of 3 by 2 plus. So when you multiply this, this becomes 2 times 3, 6 in the denominator, 7 over 6 square root of 3x minus 1 plus the constant c. Makes sense? See how easily we have solved all these questions now. So with this, I've given you solution for question number 3 and 6 completely, and 4 and 5 are for you to finish, right? So I hope that really helps. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. And keep contributing. We want to reach millions who really need quality education, and that too absolutely free. Education is extremely expensive these days. Thanks for your support. All the best.